Yes, you read the thumbnail right. No, it's not clickbait. I really have come up with a low profile 2-inch focuser that you can make at home for circa €30 £pounds. I myself paid €28 plus some printer filament, and I made 2 from that. And I have to say it works pretty damn well. So if you're the proud owner of an f4.4 to f5 114 or 130 scope, then this should be a worthwhile upgrade over your little plastic 1.25 inch focuser. Now don't let the mention of 3D printing make you click away, because if you don't 3D print yourself, you don't have a printer, there's always an answer, there's always an option. You can still get one of these yourself, even if I have to knock one up for you myself. And I will say more in the video. Do watch on. I'm Nugsy. You're watching Cheapass-tro. I've been working on this focuser project for about 10 weeks prior to recording this, and it was part of a larger project. A long time back I bought myself a Skywatcher 114 5P, which is 114mm Newtonian with a 500mm focal length, and it was only good for visual use. I recently put out a video on how I managed to attain focus in that scope with a DSLR, and the use of this focuser was part of that project, and the focuser has been the biggest side of that project for sure. What you're looking at here is a low profile Crayford hybrid focuser. What that means is it's a hybrid between a Crayford and a rack and pinion focuser. Now, a rack and pinion focuser is the normal type that you would usually get on a budget telescope. It involves a geared strip and a pinion wheel to drive the focuser tube up and down, and for the most part inside the tube are just some little nylon strips to guide that tube and hold it straight and true. This is the sort of focuser I had fitted to my Skywatcher 200p, and it was an all metal focuser, rack and pinion, and I have to say it was awful. That coming out of the factory had slop. I did make a video a while ago showing how to reduce this slop, but I could never get rid of it. So many people prefer a Crayford focuser, which actually utilises bearings within the focuser housing to keep that tube running straight and true, rather than just little nylon strips, and then it just uses pressure to drive the tube up and down. These are generally more accurate. Now, the trouble that some people find with a Crayford focuser is because it's only relying on pressure to draw the tube up and down, that a heavy imaging payload may cause the tube to slip back down under the weight. And this is where some people will then upgrade to a Crayford hybrid, and this is the same thing as a Crayford with the bearings holding the tube straight and true, but also it has the rack and pinion, and this makes it a lot stronger and hold position better. That is the kind of focuser I recently fitted to my 200p, and it has been brilliant. It's a €250 focuser, so I would expect it to be. I only got it for 60 quid because I'm savvy on the used market. But that's what I wanted to replicate for my little 114p, and I wanted to do so dirt cheap. Now, this little 114p is typical of a great many scopes out there, and I'm not just talking about 114s, but there's a lot of 130mm Newtonians in the same boat. They don't reach prime focus, and they're delivered with a 1.25 inch focuser, generally a cheap plastic one. And this is the focuser on the 114p. It's probably the same focuser on many 130p's as well. And we're not just talking Skywatcher, we're talking Meade, Orion, possibly Celestron. I say possibly Celestron because they're a bit of a law unto themselves, Celestron. They tend to put little body kits on their scopes to make them look different, so I'm not 100% sure on fitment for Celestrons. But optically, these scopes are all the same. Now beware, there are many scopes that look exactly the same as this, but they're not. They're optically different. If you've got one that looks the same but it has a 900 or 1000 mil focal length, then it's just optically wrong for this focuser, because it has an inbuilt lens in its own focuser, and this won't fix it. So if you're the proud owner of an f4.4 to f5 114 or 130 scope, then this should be a worthwhile upgrade over your little plastic 1.25 inch focuser. Not only will it allow 2-inch eyepieces, of course, but the all-important factor for me was to gain the ability to use my coma corrector for imaging purposes. So yes, a big wide range of scopes demonstrated here on my 114p. Now, to design this focuser, I actually used Tinkercad, which a lot of people would slate me for because it's so simplistic, but it works for me, and I got my results. And my intention was to utilize the hardware from my existing 1.25 inch focuser and just basically design a new focuser body and tube to work with that pinion, spring and plate from the first focuser. But when I designed, printed and put this all together, as chuffed as I was with it, because it was a working focuser, it had approximately the same accuracy as the one that came on my 200p, which means it had slop. So when testing with a laser pointing at a target, which is representing the middle of the focuser basically, where it should be pointing, drawing in and out would come off the target and back onto it, and off the target and back onto it. Now this did work, and I pulled a fairly decent image of Andromeda out of it. However, this is no good. I couldn't release this on the public. I had to improve on it. So I redesigned it to have the bearings more solidly captured in it, and it was still exactly the same. So Mark 1 and Mark 2, no good. I had to design a Mark 3, and in this Mark 3, I thought the only way... The problem is the tube is exactly so. So this is the currently available model. It has 8 bearings, it has a metal tube and a metal rack and pinion fitted to that. While I was waiting for my rack and pinion to arrive, I'd ordered it from Temu or AliExpress, I think actually. I actually looked at my 1.25 inch focuser again and thought, well, that plastic gear strip works. So what I actually did, I cut that from my focuser tube and stuck that to the tube. And it worked a treat. It works just as well as the metal one. Therefore, with still the same purchase costs, because you have to buy so many screws, and I think I bought a bag of 20 bearings and things like that, I had enough to print another focuser body, and I had one with the cut plastic rack from the 114 with its pinion and its tensioning plate, and one with the new metal rack and pinion that I purchased from AliExpress, and they both work just the same as each other. So you can, if you have an existing 1.25 inch focuser, avoid the cost of buying a separate metal rack and pinion by actually cutting the strip out of your 1.25 inch focuser and using that. So yeah, for €30 thereabouts, I was able to make 2 of these 2-inch focusers. On the focuser you see in here, you may see there's I fitted actually a focus lock bolt. I fitted to the front on this one model, but I don't like the idea because it could mash up the gears and it could also take you out of focus again. So I don't like that idea. I've changed it. It's not going to be available on the printable files. The locking bolt will be on the back of the focuser, as you would usually find on a focuser. So that's basically it. That's again, overview. 2-inch, low profile, 34mm, Crayford rack and pinion hybrid. 8 bearings holding a metal tube straight with either a metal or plastic rack and pinion. It has a self-centering adapter, and because of its low profile, by the way, it has a fairly short throw. It's only 26mm. Therefore, if you're using this as part of a project to get your Newtonian to reach focus, you have to work out how much you move the mirror to fall within this 26mm range here. Easily done. See my last video on it. So, how to get yourself one of these and how to make it. Now I should say at this point, I mentioned right at the start of this video that not everyone's got a 3D printer and may be tempted to click off because this isn't a project for them. But there is always an option. Right, now you'll probably find, if you just do a quick search, that in your area are people that offer 3D printing services, whereby you can send them your STL files. That's the files that I said you can download from my Thingyverse page, and have them print them for you. They will of course charge for this, but it's an option if you haven't got a printer. You would then get back the plastic parts and have to put us all together yourself. Another option is, in a lot of local libraries, they will have a printer for use. So you could take a little flash drive or whatever with your STL files on it and use their printer. If all else fails and it's geographically and financially viable to do so, I will offer to put this together and send it to you myself as a finished unit ready to fit to your scope. When I say finished unit, I mean like I've done in the video. Bearings fitted, tube fitted, rack and pinion fitted, the works. And if you want to get hold of one of these from myself, I'm not going to put a price on it or anything as yet because I haven't got a clue. It all depends on the amount of interest I get as to how many things I can order at once and how cheap things become. So the only way, if you do want me to send you one of these units, would be to email me or DM me on my Discord. Both links are down below. Okay, so let's get on with it. On my Thingyverse page, you'll see this bunch of files. You can download them individually, whichever ones you need, or just click download all and it comes in a zip file. Once you've got these files, in order to take them to your printer, you will need to open them up in a slicer. I'm not going to go through print settings with you. This took me lots of YouTube videos to learn, and it's not the scope of this video. This is mostly for people who can 3D print and know their own printers, because all these settings work differently for different printers. If you're using a library printer, you might inquire there as to whether someone will set it up in a slicer for you. within the slicer, you check everything's all good, and you can then export this to a G-code file for your printer. Take it to your printer, print it. Repeat for all the other parts you need. That's as much detail as I'm going to go into with printing. For anyone new to 3D printing, you will see that if you've got your settings really dialed in on your printer, you may end up with a nice clean print. If they're not really 100% dialed in, you might get some stringing and bits and pieces, and you generally will have to clean up your printer. You'll certainly have to clean up any support. So these little support trees have to be cut off. I've gone over it with a bit of a file and some sandpaper. I've actually sanded quite a bit on the body of mine because I knew I was going to give it a lick of paint. So tidy it up as much as you need, but they don't come out perfectly like factory molded, is what I'm saying. You will have to put some work into the print itself. Okay, a bit of an oddity in the print files you'll see is a hole saw guide. This is for when it comes to fitting the focuser, you are going to have to cut a bigger hole in your telescope tube. I will go through this when it gets to the part. It is vital with that part that it's printed with 100% infill if you're using it for a bimetal hole saw. Okay, so let's say you've got all your parts all printed, sanded down, ready to put together. The other bits we're going to need. Some of these parts I already had because I have like kits of various M2 to M6 bolts, but you might have to buy these yourself. So we'll be fitting 8 bearings to this. That's going to require 8 bolts as well. I bought a bag of 20 bearings. I'm going to be putting links down below to all the parts, and bear in mind over time you may have to search for these things yourself because this seller might stop trading, change prices, whatever. Anyway, bottom line is you want to look for the same part as cheap as possible. Now I myself, I paid about £7 I think for a bag of 20 bearings, but on Temu I see we're under €3, probably about £2.50 for 10 of these bearings. They are 693ZZ, or ZZ if you like. 693ZZ. That's 8mm by 4mm with a 3mm bore. So you need at least 8 of those. If you get a bag of 20 for less than €6, then you can do 2 focusers with it. For the focuser lock bolt, I've used a heat set insert. It's a threaded insert that you stick into the print with a soldering iron. And these are cheap as chips. You can get 50 of these for just over €1 in M3 size. Again on Temu. You may as well get an assorted pack if you're doing 3D printing. I've included some M3 thumb screws. Again on Temu, we're looking at like €1.33 for 5 of those things, and you would need 4. M3 by 20 bolts is next. You'll need 8 of these to hold the bearings in place, and you can get a pack of 25 for €1.31, again on Temu. Now one of the bigger parts I could not find on Temu. This is an AliExpress one, and it comes in at €6.50 plus £3.76 postage, so it's, let's say, less than €11 for the rack and pinion. It's a brass rack and pinion set, and we'll only be using half of that strip as well. So we can have the one pinion, 2 metal racks, and use the pinion off the other scope, and you won't have to use the plastic strip. And this is another Temu one. We have the steel pipe for the focuser draw tube. Now, It's important you get these dimensions right. It's a 60mm tube. That is bigger than 2 inches, yes, but it has an insert to bring it down to 2 inches. So we want a 60mm tube, and for a 100mm length of 60mm tube, we're looking at less than €5. This particular one is of 1mm steel, so it has an internal diameter of 58mm, external diameter of 60mm. A lot of them will be thicker steel, giving you a smaller internal diameter, so make sure you get the 1mm steel. And this is really hard, good steel and cheap to buy. So that's it. We got bearings, bolts, steel tube, rack and pinion, and the little accessories like the thumb screws as well. All the rest is just 3D printed stuff. So step 1. You have the body of the focuser all cleaned up and ready to go. You might have put a lick of paint on it, make it look nice, up to you. But you've got to make sure, as we're about to fit the bearings into this body, that the bearing holes are free of any stringing, and I would just sort of wave a lighter in there, not too long to burn it, obviously, or melt it, but you just want to get rid of those little strings, maybe scoop it out with something pointy. And then we're going to take our bearings and M3 by 20 bolts. You simply slot the bearing into the little gap. I here used a little pokey bit just to make sure the holes lined up. And then the M3 bolt will literally self-tap into these printed holes. It's printed at just the right size. So you can start it off with your fingers and then Allen key drive it all the way in. It's a 2.5mm Allen key. And once that's seated all the way in, that bolt will go through the bearing and into a hole on the opposite side and hold that bearing solid where it is. Rinse and repeat 8 times all the way around. Make sure they're driven home, but don't over tighten because it's only plastic you're driving into. You could just strip threads out. But once you've got all 8 bearings seated in there, you can feel that they run nicely, then that focuser body is ready for the tube. The tube itself is going to need cutting. Alright, so we want to first of all measure up against the focuser insert perhaps, that's printed up already, and mark it off, and we want to cut this as straight as possible. Now I did this 2 ways. The first time I did it with a small angle grinder, one of the thinner bladed angle grinders, up in the workshop in a bench, and to avoid damage to the tube I wrapped it up in some rag, and that worked fine. Second time I tried this, I tried with a little Dremel type cutting tool, and I had to give up on that. It was just tedious. It's very hard steel, this stuff. So I ended up hacksawing through that one. Whatever way you cut it, you're going to need to deburr the end that's been cut with a file, and then the insert will just slip inside it. I missed the footage of applying the glue, but I've taken it out to show you here. I have just sparingly put some 2-part epoxy resin around that plastic insert before I slide it into the metal tube, and you leave that set. Now for the rack and pinion, we're going to fit this to the tube. First of all, this rack needs to be cut in half if you've bought the brass ones from AliExpress, and a little Dremel is fine on this. This is nice soft metal, you can cut through that no problem. I went to the extra effort of cutting a few teeth off on the other end and drilling a second hole, because my plan was to bolt this to that steel tube, and my plan was foiled by the hardness of that steel tube. I could not drill it. I could barely scratch it with a drill. I gave up on it, and I just glued it to the tube at the end with, again, a good glue. I used a 2-part epoxy glue. Now it is imperative that when you glue this in place that you glue it straight and true. So rather than using a square, I used the actual body of the focuser itself. So I put the tube into the focuser, put the rack in there, and made sure that it's straight with the gap in the focuser, and then holding that in place, and take it out and mark it, and then you can glue it in place. Now you don't want this sitting on a big bed of glue where it might be higher on one end than the other. So when you do glue it in place, squish it down against the tube so it's nice and flat all the way along. Scrape off any excess glue and leave it set for a good while. Now when I came back to this the next day, everything was working well. It would draw in and out, but it would draw out past the bearings within the housing of the focuser. So we have to put a stop on this brass rack, and that was originally going to be just the head of a bolt, but because I couldn't get a bolt in there, what I ended up doing was cutting the head of a bolt off a bolt and sticking that again with this glue where it would have been. I trimmed it down once that glue had all set, and with that stop in place, that focuser can no longer run past the bearings and sort of come off the rails, so to speak. Okay, so we've got a good working rack and pinion system there. When it comes to the rack and pinion, yes, when we put the brass pinion in here, there's a 3D printed cover that will slip over that and pressure that down, and I just used 2 M3 bolts. I think they were M3 by 16 or something like that this time, shorter bolts anyway, to drive those into that and pressure the plate, pressure the pinion against the gears, and then, well, that's it. It's basically done, a working focuser. If you're using parts from your original focuser, your little 1.25 inch focuser, same thing applies, but that's going to have a little spring plate as well, and then its own metal plate, and you can use that and its own screws if you like to again pressure down on your pinion. Now there are 2 different sets of filter knobs available, and the shorter looking set, the shorter squarer looking set, are to go with the brass type because they have like a little D on the end, and there's a printed D hole on those focuser knobs that are a real tight fit, and they're done so on purpose so you don't have to use anything else to affix them. So what I ended up doing was literally just sort of tapping those onto the shaft, and they're not going to come off without some effort. If you're using your original 1.25 inch pinion, it has shorter arms on it. It has a shorter shaft, so it uses the extended knobs to bring it out further, and you're going to need some heat set inserts in that. I think, yeah, the M3 again. So M3 heat shrink inserts into the ends of those things, and they will just then screw on to the end of the shaft. You could use a little thread lock or a little glue if you like as well. Oh, one more thing, when putting it back together, is a little bit of lubricant wouldn't go amiss. On this rack and pinion I used a silicone spray. They say silicone or lithium grease, something along those lines, because it's plastic safe. Finally, just to finish off at the top, I've put these 3mm M3, that is, knurled thumb screws, and there are 3 holes around the top of the focuser tube, and they again are printed to the right size, so you can literally just cut your own thread with these screws. And that's it, that's all together, working focuser. Now to fit these to your tube, Yes, this is the destructive part. You're going to have to, on having removed your 1.25 inch focuser, you're going to have to cut a 2-inch hole. Well, in my case I cut a 64mm hole in there to allow for the 60mm tube to go in there. I used a 64mm bimetal hole saw, and I only used it when the tube was empty. I took everything out of it and just worked on a hollow tube for this one. No mirrors, no spider, get rid of it all. And with that tube held as firmly as you can, mark the centre, hold the saw over it, whatever, but I used a hole saw guide to actually ensure that. It's a 3D printed part, and it simply just slots over the drill bit on the hole saw. That fits the 1.25 inch hole and will hold it centrally over that. So when you drill in, it will make a bigger circle concentrically around that smaller circle. That's a good word for me, wasn't it? Anyway, do not make the mistake of using a lesser infill if you do 3D print that hole saw guide, because my first one fell apart and I made a bit of a mess doing so. It was all covered by the focuser in the end, so not a bother, but do it first time, 100% infill. It's got to be solid or you'll just rip the middle out of it. It'll take some doing and it might get a bit jaggedy, whatever, but persevere and you'll cut through and make yourself a bigger hole. You will also need something like a Dremel or a hacksaw, and some pliers will do it. You need to take that little nick out as well for the rack to travel down. So once you've got that all cut and you've filed off and made the edges safe, then you can center your focuser over it. And what I did at this stage, I actually put a 1.25 inch adapter in that focuser with a laser in there to make sure that the laser is hitting a mark that I previously put opposite the focuser by measuring up. You can see how I did that in more detail in the video at the top of the screen now, which was how I fitted my focuser to my 200mm scope. But you basically make sure you mark exactly the center. I just scratched a little cross in there and hold that focuser then so that your laser is pointing bang on that little cross. Then you can mark the holes, maybe mark them with a little drill if need be, or like a pointy pen of some sort. One way or the other, mark the holes and then you can drill those holes. Once they're fitted, I would recommend a little smear of mastic just around the bottom of the focuser itself. Hold it in place and get your bolts in and tightened up. Recheck with the laser, and if it's on position and everything's tight, clean out your tube because it's likely to have swarf in it, and put it all back together. Congratulations, you now have a tube with a 2-inch Crayford hybrid low profile focuser. Wow, wasn't I good to you, giving you all that for free, or nearly free. Free from my part anyway. You can tip me for having saved you lots and lots of money. I do have a buy me a coffee thing down below. There's a thanks button down below. I was thinking about just sort of selling these and charging for them, but no, that's not what I'm about. I want to give to the community, those that can't afford it. But those that can afford a tip, then please do. I've worked hard on this one and I think it's worthwhile. Any questions for me, any suggestions on improvements, anything like that, pop them down in the comments below. If you haven't got anything you need to ask, comment anyway, because it really helps this video reach a wider audience. YouTube does not know what to suggest to people's feeds. and it's only by viewer interaction, as in likes and comments, the only things that tell YouTube that this is going alright. Let's try it with some more people and get it out to more people. Without your interactions, this video is going to probably be like my last one, with a few hundred views, and it's like nothing in the scheme of YouTube. This, I believe, should go out to a lot more people, a wider audience, because I think this is a good product and it's dirt cheap. I really hope you print one of these, make one for yourselves, order one from me, whatever needs be. But I really hope you do get one and enjoy it, because with this final version, it does, as I said, run straight and true. I have taken the slop out of it, and here's a shot of me with that laser test on the cross, dialing this in and out. And you see it doesn't move from the spot. It is a proper working focuser. I think all has been said now, so enjoy it. Thanks for watching, and I shall see you next time. Clear skies, everybody.